Hello everybody, I will start my today another live coding session. In my today's video, I will solve this question. One added distance. So I'm given two strings S and T and return true if they are both want this added distance apart. Otherwise return false. Okay. So input should be two strings S and T and the output should be Boolean. Okay. And a string S is said to be one distance apart from a string T if you can insert exactly one character into S to get T. Insert exactly one character insert to S to get T. Okay. Delete exactly one character from S to get T. Yep. Replace exactly one character of S with a different character to get T. I see. Okay, so in this question, yeah, I will be given two string and I will return the boolean and I will check the boolean should represent if S can be somehow edited and converted into T, yeah, with either of these three operations. So let's say S is A, B, B, and T is A, B, C, B. In this case, I can delete the C and I can get ABB, so I will return true. Good. However, if S is ABC and if this is AB, say XYZ, in this case, I have to delete two characters XY, so it should be false. Okay. So I will think of some edge cases. So edge case is that empty string and empty string pair. In that case, yep, as I can see in the example, it should return false. So interesting is that it always have to be one distance apart. So ABC should return false because they are zero distance apart. I understood. Good. Okay. Now I understood the question, so I will think how we can solve this question. So as a brute force approach, from the given S, I will try this operation number one for every character and check if S is converted into T. If true, I will return true. And I will do the same thing for the second operation. And I will do the same thing for the third operation. So in this way, there should be three kinds of operation. I'm thinking about the time complexity. So for the first operation, assuming this, oh, yeah. So there are NS positions I can insert, and S and T consist of lowercase letters, uppercase letters, and digits. There should be 62, yeah, characters. So I will try all of them and compare with T. Yeah. And I will do this 3 times basically because for the second one, there are NS characters to be deleted. Oh, is that it? And I will check the deleted remaining characters with ST. Or in the third operation, I have NS characters I can replace, which are represented 62 characters, any of them, and then I will compare with the NT. Oh, sorry, it should be this one. wait, and t times and t, sorry, and times and t. Because after choosing the character, I will think which character to be replaced into. Then for each, I will compare with st. So the time compressor should be like this. This should be ns times s and t. Yeah, seems like this is acceptable to some extent. So yeah, definitely this is one of the um, possible option of the solution, I think. Okay. So let's think of the optimized approach. The first thing I can say is um, I can compare length of s and length of t. And if I mean length t is longer than length t, which means that the only possibility is like this. Yeah. And there's the same. Obviously, this is possible only if I do the operation number 3. And if length s is smaller than length t, the only possibility is that I do the operation number 2. No, this is their opposite. This should be here, and this should be here. So, and otherwise, what I should say, maybe this is more accurate. Yep. Otherwise, I should return false because no matter which operation I take, S cannot be converted into T. So now I could, you know, um, break down the question into 3 patterns and everything each of them. I think this one, the second case is very simple. Yep. So I can use the 2 pointers and compare each character on the same position in S and that in T. And if only one character is different, it's true. I mean, with one edit distance. So this is what I will check here. And number 2, I mean, sorry, so I mean, I will think of other cases. So this case, yeah, I think you can probably use the 2 pointers again. So let's say ABC and AB. In this case, IS can skip only once. So if characters are different, index S should be skipped only once. Or, I mean, that's the case when like this. In this case, I should skip exactly once. That's the condition. Another case, if the character here is, I mean, if, in the case, S has one more character than T, and that excessive character is the last character. In this case, after finishing the duration, yeah. So that's end, and I can say no skip sulfur. So in that case, because I've already confirmed that S has one more character than T, so I can say S and T run at a distance now. Good. Or maybe I can generalize more. So I will move 2 pointers until this one, until the second to last index of S, and compare the different number of characters. And the number of different characters between that substring of S and T is 0 or 1. I can say there is one at a distance. Wait, what I'm saying? No, I said completely wrong. Please just forget. So I mean, I have to check because sorry. So if I skip some character in S, I should ignore that, and I have to keep checking S and T. One character shifted. So that's what I have to do. Yeah. But basically, what I can say is, what is expected is that when when the iteration finishes on IT, IS condition should be one character skipped and currently here, or no character skipped and here. Yeah. One character skipped. What I should say. So iterate index T, IT, and when it reaches end, one or two chairs skipped. Sorry, 0, 1 chairs skipped. That's the condition. And when one character is skipped and others are the same, IS is now end of here. It's okay. And no character is skipped. Now index of S is second to last character, but there is one character remaining. So I can say there's a one edit distance. Okay, so this is how we can check line 37 case. And for line 43 case, I can use the technique, the same logic I told in line 30 just now. So swap S and T and check case 1 logic. Yeah. So for example, S is say A, B, and T is A, B, C. What I would do is swap them. So it should be AB and ABC. And then I just have to do what I did here before. So in that way, I can kind of omit, save some time and implementation. Okay, so that being said, I will do this complex analysis. So I thought of 3 cases. The number 1 case, either the 2 pointers, and I should say I'm thinking about the worst case, and the worst case is that length s is almost length of string s is almost equal to length t. Otherwise, I can just outright return false. So I'm thinking of the worst times complexity. So in this case, si is equal to st. And that being said, so length of n s is equal to length of t. Yeah. And I did the 2 pointers, and the 2 pointers move in the same speed, and they have to consume ns characters. It should be ns. So this is the case 1. And for case 2, the same thing happens. I do the 2 pointers, and each of s pointer and t pointer moves in the same speed, and they have to consume s ns characters for each. They should be ns. And for third one, this is exactly the same as the first one, so it should be ns. So it should be O of ns. Okay, good. And for space complexity, I'm pretty sure this is fixing with the constant time. No non-constant data structure. Okay, so now we're implementing cloud implementation. And whatever check here in line 58 is self dot one character inserted. S and T. And when I check this, I expect that length of S is longer than length of T. So yeah, S should be longer. Or maybe I should say string 1, string 2. Maybe this is more, generic. So whatever check here is if I insert one character to string 2, I can make it to string 1. So that's what I would check. Yeah. As I said, I can use it in the third case by swapping S and T. Yeah. Let me rename this. Is one chair insertion. And this one is one chair replacement. And here in this method, I expect that string 1 is equal to length of string 2. Yep. Then I will call this method here. Good. Okay, so now I will implement these two sub-methods. So probably this one, the second one is easier. So let me start it first. Okay. So they move in the same speed. I need only one index. And if diff count reaches 2, immediately I can return false. This is optional actually. Yeah. But yeah, that's how it works. And in the end, I will return diff count is equal to 1. Because that's what I expect. Again, this line 7980 is optional. Yeah, this I will return just speeds up. Okay, now I will implement line 69 is one char insertion. And string 1 is longer. Okay. So look like this. So firstly, I have to sync, as I said, these two cases. So I move the pointer I2 on the second string, and I move I1 accordingly. So what I would check is if there's the same, I move the I1 pointer. And otherwise, they're not the same. So I will take it as the insertion and I will move the character. I don't, yeah, I will move the character. So simply saying, I can refactor this in this way. So if I1 and I2 are not the same, like this, I increment num insertions here, then I move I1 pointer. Yeah. Oh, but there is a possibility the stairs they are not the same. So I still have to check with this one is I2. A bit complicated. Let me think of a better or maybe simplified approach. Yeah, so now I'm inclined to use 2 pointers moving in this way. So I will keep doing until I2 is smaller than string 2. So until I2 goes out of the range, I move. I keep doing. And first thing I will do is compare these I1 char and I2 char. And if they're the same, I move both of them But if they're not the same, I move only char I1 or index I1. Yes. Otherwise, I just move I1. And I increment num insertions. Yep. Then I keep going. So for example, in this case, B is moved here, I1 moves here, and then X and B, comparing them, and I find that they're not the same, so I move I1, and now number insertions is 1, and now they're not the same, so again I move this, which means that if num insertions is 2, I can just return false, because they're not the same anymore. Sorry, it doesn't meet the condition anymore. Okay. So basically how all these things work. For example, this case, I move I1 and I2, and now here, num insertions is 1, and I move this, and I move I2 and I1 at the same time, and that's the end. Yeah. Okay, so when I2 reaches the end, there are two cases expected. Number one case is I1 is still in the string 2, string 1 range, and at the end of it. Yep. So, and num insertions is equal to 0. In this case, all of the characters are the same software. Yep. And I1 is now the last index. Or num insertions is 1, and I1 is I1 has just consumed all the characters. So yep, this is another case. So I should return either of this. Sorry, I should return true if either of this is true. Okay. Maybe I can simplify a little bit more. Let me think for only 30 seconds. Yeah. Okay. Maybe for this case, I can skip this. If I skip this, I can still do the same thing, right? If in the line 96, in this case, there is one last character remaining in string 1, and so far all the characters are the same. Yeah. Or I1 has just consumed all the characters and only one character inserted. Good. Yeah, so even if this doesn't exist, it works, but just for the optimization, I leave this. Good. Okay. So let me quickly check my code. Yeah. I will focus the test on these some methods. First, the main method, is one edit distance method. I'm pretty sure this is correct. What I'm doing is quite simple. So I will focus on the test of these two sub methods. And I will do this each one character replacement case first. I will do the dry run for this. So I will check AB case and AB and AC case. This should return false. This should return true. And maybe this should return false. Sorry, expected false, expected true, and expected false. Okay, I will quickly check. So for all of them, yeah, it meets this condition, and diff count begins with 0, and in line 118, I move index I, and when index I is 0, string 1 is equal to string 2, so now diff count is 1. Good. Then I go back to line 120, and I is now here, index 1. So two characters are the same, so diff count is incremented by 1. It becomes 2. Wait, this isn't correct. Diff count should be, here, not equal. So now I can say diff count is 0, 0, 0, because A is not A, it's false. In integer, it's 0. And when I move into index to index 1, B is not B, it's false. So diff count is 0, 0. So I return false. Okay. Good. And ABAC case, this one, where index is I is 0, A is equal to A, so diff count is still 0. And I move index I, so now index 1. In this case, B is not C. Yeah, it's true. So diff count is now 1. And I go out of the loop and I return true. Good. And ABXY case, I start with index I is 0. And now A is not X. So diff count is now 1. Yep. Then index I is now index 1. And now B is not Y. Yes, so diff count is now 2. So I return false immediately. Good, passed. Okay, I go back to line 28 and I will check this test, do this test. So again, as I said, the test cases I'd like to check is this one, or this one, or this one. Yep. So in this case, expected true, and expected true, and expected false. So simply saying, this is the case, one inserted character is the last character. This is the case when inserted character is not the last one. This is the case. There are different chars. Excluding one insertion, there's still a different char. So these are 3 test cases I'd like to check. Okay. So I will check this first. I1, I2 start with 0. Yep. And num insertions begins with 0. So I2, 0 is less than 2. Yep, this is true. So I compare string 1 and string 2, and they're the same. So I move I1 and I2. And now I come back to line 94, and I2, index 1, is less than 2. Yes, I compare B and B, and because there is the same, I move I1 and I2. Now I2 went out of the loop, so I take a look at line 104, and now I1 is equal to length of string 1 minus 1. So this case, and now insertion is equal to 0. Yep, so I return true. Good. I passed this test case. Okay, and AXBAB case, this is a case 2. I will speed up. So first 3, char1 is equal to char2, so I move I1 and 2. Now I1, char1 is not char2, so I go to 101, and I move only I1. And number insertions is now 1. Good. Now here, I go back to while loop. Yeah. And now I2 is still inside of the range. Yep. So I compare them again. And now I1, char1 is equal to char2. So I move I1 and also I2. Now I2 has gone out of the range. I finish the while loop and I check. And currently I1 is the length of string 1. Yeah. And number insertions is now 1. So I return true. Okay. So this passed. The last case, AX and AB. I start with this. And firstly, char1 is not char2. So, sorry, char1 is equal to char2. So I move I1 and I2. And now they're not the same. So I go to line 104 and I move I1 only. And now expect insertions is now 1. Yes. Then again, I compare I1 and 2, char1 and char2. They're not the same. I move I1. And now insertions is plus 1. So it should be 2. At this moment, now insertions is equal to 2. I return false. Okay, as expected. Good. So that being said, I covered all the lines in this method. So I'm pretty confident in my code. So I submit. Oh, indentation error. I see. Oh. AB and ACB. Insert exactly one character into S to get T. So this is the case when 2, 3, so this one. So in this case, is one character insertion T to, yeah, I mean, there should be one character insertion to, sorry, so now string 1, string 2 is, so I said 2, 3, 2, 3, so 2, 2, 2. Hmm? Oh, no, it should be like this. So I'm expect string 1 is larger than string 2. So string 1 is longer than string 2. So in this case, yep, I should call it in this way. But in this case, I should swap and call the method. And again, my mistake was that this plus 1 should be on the left side. Hmm. So now this is code with ACB and AB. Actually, I tested in this in here. Ah, no, I should return here. Okay, good. I submit my code. Accepted. Okay. Okay, so in my today's coding session, I solved this question, one edit distance. And I was given two characters S and two strings S and T, and returns a boolean if they're one edit distance apart. So basically, my idea was that I thought of three patterns of the ranks, combination of ranks of S and T, which can be one edit distance. And for each, I use the 2 pointers to check it one character insertion equivalent or one character represent equivalent. And the small technique I used here is that insertion and deletion method are completely reversing ones. I mean, inverse operation. So I could use the same method with argument order reversed. Okay, so that being said, I finished my today's coding practice. Thank you so much. Bye.